Welcome to a nice little review. I call it a co-rec topic because it's kind of a review of polynomial arithmetic. This is going to be good stuff. Now, for most of you, this is going to be a heck of a review. You're going to say, yeah, I've seen most of this before anyway. But I would ask that you what's the word I want to use? Settle in, enjoy the show, and you may pick up some tidbits, some very important tidbits. So, first of all, what's a polynomial? We'll start going through our vocab list here. What's a polynomial? Well, I'll show you one. First of all, let me erase that. Okay, I'll show you a polynomial. You ready? A polynomial, and here's one right here. 5x squared minus 2x plus 6. That's an example of a polynomial. What is that? It's a collection of terms. You'll notice there's three terms here. 1, 2, 3. It's a collection of three terms. Collection of terms. That's an of. Okay. Collection of terms. Yeah. And the thing is, you can't just be any terms. They all have to take a special form, which all take the form. And the form has to be some number. So I'm using an a just to say any number you want. 2, 3, -8, whatever. Square root of pi, whatever the heck you want. Any number. So that's any number. And then you have an x. That's what makes it algebra, right? We have an x. And then the x has to be to some whole number exponent. The exponent has to be a whole number. So notice that this term certainly fits the bill. I got a number, it's a 5. I got a whole number exponent, it's a 2. So yay for that. And then the next term, by the way, the negative would 2x is that's the whole term right there, the negative 2x. It's got a any number in front, in this case a -2, and it's got x to a whole number. In this case it would be x to the 1 power, right? By default it's a 1 power. And then this term counts too, the plus 6. Why? Because it's any number, it's a 6. And you might be saying, hey, where'd they put the x, man? Come on, man, where's the x? And it's like, well, it's hiding. Because if you had x to the 0 power, and 0 is a whole number, whole numbers are 0, 1, 2, 3, right? They go up like that. Not negatives, but 0, 1, 2, 3. Those are whole numbers. Anyway, x to the 0 is 1. Pretty much anything to the 0 power is a 1. Pretty much anything to the 0 power is 1. Not 0 to the 0, but anything else. So usually we don't write the x to the 0. We just leave that out because it looks, well, it's faster to write. It looks better. But anyway, this is a polynomial. All three of these count as terms of the form ax to the n, a number, an x with the whole number exponent. Okay, get the idea? Now there's a more vocabulary. You can see I listed some terms up here that we're going to look at. So standard form, STD, standard form of a polynomial would be basically arrange the exponents from high to low. Arrange the exponents from high to low. That's what you got to do. So let me see here. Yep. Where am I? I'm on my notes here. Well, gee. So if you had something like, well, you wouldn't want to put the -2x first and then the 5x squared and then the 6. No, that's not standard form. And by the way, when we say exponents go in order, I'm not talking about like here, like say 5x squared minus 2x plus 6 to the 48th power. Okay, you might look at that 48th power and say, oh my goodness, that's a huge exponent. Should that term go first? And the answer is no, that term doesn't go first. What matters is the exponent on the variables. So actually, this is in standard form right there. So again, when we're talking about the highest exponent to lowest exponent, we are talking about exponents on the x. That's a 2, and then it's a 1, and then this is actually this is, well, again, this is like an x to the 0, which we usually don't write. So, okay, that's standard form. Now, taking a look back up here at our nice example, our first example of a polynomial, we got some more words to learn. Terms. When we talk about terms of a polynomial, They're the things separated by either adding or subtracting. So in other words, 5x squared would be a term, negative 2x would be a term, positive 6 would be a term. I say they're separated by adding or subtracting because really I should say separated by adding, because you can think of this as plus a negative 2x plus a positive 6, right? So technically there's an addition in between, but when you're looking at this thing up here, of course, you're just going to say, it's a minus, it's a plus. They're separated by adding and subtracting. So forgive me if I'm not being a strict mathematician with my definitions. I was an engineer in a past life, so, I get by waving my hands around for the most part. But you get the idea. It's like the things that are separated here. I got a 5x squared. That's a term. I got a minus 2x. That's a term. I got a 6. That's a term. Okay, cool. Now there's another word we got to know, factors. I'm going to throw a lot of words around in this course. It helps to know what they mean. That way you don't have to go, You don't have to keep guessing what the instructions are every time. So factors. Well, for example, or why don't I say it this way? Give you the definition first. So they're things that multiply together to give you a term. Or maybe I'll say in a term. So for example, the 5x squared has factors of, you could say it's a 5 times an x times another x. So the 5 and the x, those are all factors of 5x squared. I mean, you could, if you wanted to, say it's a 5 times an x squared, I suppose, if you wanted to. But I'm breaking it all up into its prime factors. It's a 5 times an x times an x. Or the negative 2x has factors of a negative. Well, you know what? Let's be careful here. I'm trying to be careful here. Okay. I'm going to think of this really as a negative. Hey, you. Negative 1 times 2 times x. Often it helps to split that negative 1 out, or at least to think of the negative 1 separately from the 2. Think of your negatives separately from your 2's. It's going to be a handy tip that's going to come up in the future. I suppose the 6, the 6. You could say has factors of 1 times 6, or if you wanted to, you could break it up a different way, 2 times 3. I suppose if you want to get clever about it, you might say, hey, it has factors of negative 3 and negative 2, or anything. If they multiply together to give you the 6, they're called factors of the 6. Okay, so now I'm going to mess with your head. Oh, look at this, I ran out of paper. I know how to fix that. I learned this cool trick on how to fix that. Let's see if I can remember how this goes. Some kind of cut thing, right? So watch this. I'm going to take all of this, and then I'm going to shrink it. I shrank it. Ain't that cool? Okay, now I'm going to take all of this. I'm going to shrink it. Oh, hey, come on, you. You got to love that about touchpads. Come on, what are you doing to me? All I want to do is shrink. Come on, shrinky. There we go. And then I can move it up too, right? Do. Cool. So I just made more room for us, which I like, because I got more terms to talk about. Term factor. Okay, what else we got? Oh, I wanted to mess with your head a little bit. Mess with your head a little bit. So I'm going to put something down here. Boom, 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 boom. Boom, diddy, boom, 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 boom. I sure hope the microphone's working. I'd hate to have to do this again. Anyway, messing with your head. Question is, in a new color, identify the terms and factors in this expression. Can you do it? Think about that for us in this expression. What are the terms? What are the factors? Terms are separated by adding and subtracting. So basically, that's a term. That's a term. It's a 5 times an x minus 3 plus a 7 times an x plus 4. Now, the factors of the first term, are 5, and you would take this thing, it's grouped. The parentheses say, hey, that counts as one object. Group it. So the 5 and the x minus 3 count as the two factors of the first term. And then obviously the second term, you kind of do this similar thing. 7, and again, the parentheses say, hey, group it. That's a single object. That's just on x plus 4. It's a x plus 4. Just say it real fast. X plus 4. Okay, so those, we got 4 factors here, really. Our factors are a 5 and an x minus 3. Those are 2 factors of the first term. And then a 7 and an x plus 4. Those are 2 factors of the second term. We got 2 terms. We got a total of 4 factors altogether. Now, I suppose if you wanted to, you could then go further and say, hey, doesn't this have 2 terms? It has an x plus a 4. And it's like, yeah, I suppose you could do that. So we got 2 terms with factors, and these factors have terms in themselves and so on. But you would not say that this x is a term or a factor of the equation, not or excuse me. Woo, I said a bad word. Of the expression. You would not say x is just a factor of this expression. Okay, which gets me to, I'm just coming up here to look at our list again. So we talked about the polynomial, the standard form. We talked about the term versus factor. Okay, expression versus equation. This is actually an important point. It's so important, I'm choosing a new color. Is it red important? No, but it's purple important. Okay, expressions. What's an expression? All of the things I have written on this page so far are expressions. Yes, they are. That's an expression. This whole thing's an expression. You know, that whole thing's an expression. These are all expressions. They're expressions. Everything I've written on this page so far, that's an expression. That's an expression. Yeah, all of these things are expressions. So what do you want to say an expression is? I'm going to say an expression is, well, a collection of terms and factors, maybe? Say it that way. Any collection of terms and or factors, like all the things we've written on this page so far, like I say. Now, it's important that you understand the word expression as contrasted with the word equation. Equation and expression do not mean the same thing. Nothing I've written on this page is an equation. None of these. None of the above are equations. No, they're not. They are not. Please do not use the word equation, even though you heard me slip. It's easy to slip, but you got to catch yourself. You got to put a rubber band around your wrist, and if you make a mistake, whack, make it hurt so you'll remember. Do not use the word equation. Don't, it doesn't apply to everything. If you want to be an equation, what you need, 2 sides, or maybe I'll say 2 expressions. 2 expressions joined by an equality. So in other words, if I go take any expression in the world, 5x, that's an expression. Take any expression in the world, 0, that's an expression. Okay, this counts as an equation. Okay, so I'll put example here. That's an equation. It has 2 sides. It's joined by an equals. So I'm mentioning this now because one of the most common things I see on a test is I'll have something like an x squared plus a 2x plus a 4, and the instructions will be asking you to do something with that expression, and what people will do is they'll say, hey, I feel like saying it equals 0. And it's like, no, you can't do that. You can't do that. The instructions are not going to say solve the equation, because you know what? It's not an equation. So don't make it an equation. Don't say it equals 0 if it doesn't. If the problem doesn't say it equals 0, you cannot make, that's a huge assumption you'd be making. Oh yeah, that all equals 0. How do you know? It could equal 48 for all you know. You don't know. So anyway, do I make my point? Please just, recognize equations have 2 sides to them, and you can't just give something a side if it doesn't have one in the first place. You can't just say, I feel like saying it equals 0. You can't do that. Don't do that. Please. Hopefully I will have helped prevent you from making an error somewhere along the line. Anyway, this whole first page was all just some vocabulary, right? What's a polynomial? What's standard form? What's a term? What's a factor? What's an expression? What's an equation? These are all the important words you need to know. So we move to page 2. What do you say we start doing the arithmetic part? the title of the lecture is, after all, is Polynomial Arithmetic, right? So arithmetic means add, subtract, multiply, divide. And now we know what polynomials means, right? Okay. We're going to add these two. Notice it's two polynomials. This one's put in a group to say, hey, that's one object. It's a polynomial object. Here's another one. Yay. Okay, so now we're going to, well, it says right there in the middle, add them. Okay, so we're going to add them. Here's what you can do. You can turn the page on my notes. That's what I can do. Here's what you can do. You can line them up like this. What you do is well, there's a key phrase here that you've heard before. Like terms, right? Like terms. I'm going to write the 5x squared plus the 3x minus the 4, and now I'm going to add this on, but I'm going to line up like terms. So notice this is a 6x. Looks a lot like, I guess I don't have to put the plus there, but I am. It looks a lot like a 6x. In fact, I don't. There, that's good. And then the 2, that looks a lot like a 4 in the sense that it's like x to the 0. This is like x to the 0. This is what we mean by like terms. The powers on the x match. If it's got an x, then the powers on the x match. So this is these two terms are like because they're both x to the 1 power. These two terms are like because they're both x to the 0 power. You line up your like terms, and then you add like terms together. So put a big plus over here. So I got the 5x squared, which is the only term that has x squared. Then I have the 6x and the 3x. That adds up to a 9x. You just have to add the numbers. It's kind of like I got 3 thingies plus 6 more thingies. Oh, you get 9 thingies. What are those thingies anyway? They're x's. Oh, cool. So you get 9 x's. Yeah, I got 9 x's. Okay. And then we got a minus 4 and a plus 2, which is just pure numbers. So negative 4 plus a 2 is a negative 2. And that's how you do it. That's how you do it. Let's see now here. Shall we do another one? Again, it's all about like terms. That's worth highlighting. It's all about like terms. So I'm just going to write my first polynomial. First of all, you recognize addition because I got some stuff here plus I got some stuff here, right? It's an addition of two polynomials. So I'm taking the first polynomial and I'm shoving it there. Now I want to add the other polynomial, and you're going to line up like terms. So I've got a 5x squared. That's going to go with the x squared. I got a minus 2x. That's going to go under the x. And that's all I got. Time to add. Sometimes I'll put the add in a circle like this. So negative 3x squared and 5x squared. Got a couple of x squared terms. A negative 3 plus a 5 is a 2. Notice the negative 2x and the plus 2x just go poof. They cancel, right? And then you still get your plus 1. So there's your answer. Okay, cool. That's adding. It's all about the like terms. All about the like terms. When you're subtracting polynomials, again, it's like the like terms. It's about the like terms, but it's also about one other thing. It's something called distributing. So I'm going to say distribute first. Then add like terms. Sometimes I say combine like terms. It's the same thing. Add like terms? No, terms. Terms. So, how am I going to do this? I'm going to say it this way. Now, instead of, I could, you know, do the old write this one on top, write this one on the bottom, but I kind of don't want to do it that way. I'd rather just do it the way we usually do it, which the way we usually do it is we just say, hey, I got a 3x here. I got a 6x here. So those two are going to get combined. I got a negative 4 here. I got a plus 2 here. They're like terms. They're going to get combined. But before you do that, don't do that yet. Before you do that, see that negative? That basically says that I've got my 5x squared plus my 3x minus 4, and I'm subtracting a 6x, and I'm subtracting the 2. You're subtracting both of those things, right? This negative here is saying, hey, subtract everything that's in the group here. So I guess the parentheses is the important thing, really. The parentheses is saying, the parentheses is saying, hey, man, we're all the same. And the subtraction is saying, hey, man, I want to subtract. So you have to subtract both of those things. So you have to subtract the 6x and you have to subtract the negative 2. Now usually people look at this as, they call it distributing. It's kind of like the negative think of it as a negative 1 if you want. The negative 1 multiplies the 6x to give you the negative 6x. And then again, the negative 1 out front comes on in and multiplies the positive 2 to get you a negative 2 here. Okay, that's called distributing. Anywho, now we can do the like terms dance. Let's do the like terms dance. I'm a 5x squared, and I'm the only thing that has an x squared, so I'm all by myself. But here's a plus 3x, and then there's another x term right there. Them things are going to combine or add together. You just add the 3 and the negative 6 to get a negative 3x. Okay? And then you've got the two leftovers, the negative 4 and the negative 2. They're also like terms, so they go together. So boom, there you go. You in the mood to try this yourself? You don't want me to have all the fun, do you? Here, try this one. Give it a twirl. You can pause, you know. Okay. Back already? Got it done? Okay, let's see. I'm going to do that distribute idea first. So think of this as a negative 1 times that makes a negative 4x squared. Think of this as a negative 1 times a 2x makes a negative 2x. And then, very important, think of this as a negative 1 multiplying a negative 2, giving you a positive 2. Okay, so you distribute first. Then it's like terms. Now, there's only one x squared term. Again, so that term goes first. You want to be in standard form, put the highest exponents first. Then you look at these two x terms. This is by default a positive 2x. This is a negative 2x, and those add to 0, so you don't have any x terms. And then you've got your plus 2. So there you are. Cool, right? So one more example on this add subtract page. See what you make of that. Subtract 2x plus 7 from the sum of 3x plus 2 and 8 minus x. Let you think about that for a second. Well, you gotta read words carefully in a math context. Okay, so it says subtract this. Okay, from what? From the sum. Okay, it doesn't say to subtract from that. No, it doesn't. It doesn't say to subtract from that. No, it doesn't. It says to subtract from the sum. What sum? The sum is what you get when you add these two things together. So first you have to add these two things together. You have to add the 3x plus 2, and then you have to add the 8 minus x onto that. Somebody's being nasty. That's not standard form, but what are you going to do? Not everyone's polite. So there. So we're going to add those two together. And then we're going to subtract this from it. Take that from it. Now the word from means I'm subtracting over here. And if you need help believing that, imagine if I had a statement that was all numbers. Subtract 20 from 90. What would you do? You'd go 90 minus 20, right? You're taking the 20 away from this. You start with the 90, you take away the 20. So we're taking this away from this. So first you add those two things together because that's what the sum means, and then you subtract the 2x plus 7 from that. Okay, here we go, folks. So with this plus here, I don't, you can think, I suppose, like we did with subtracting. I said distribute the negative, but distributing a positive isn't going to change anything. In fact, I'm going to do that just because. Positive 1 times 8 is 8. Positive 1 times negative x is negative x, right? Didn't change anything. It's just plus 8 minus x. So anyway, the 3x and the minus x makes a 2x. The 2 and the 8 makes a 10. So there's that. And now, over here, make sure, because of this parentheses here, it says, hey, we're all the same object. You got to treat us the same. If you're going to subtract the 2x, you better also subtract the 7, man. You got to be fair. That's kind of what that is. I'm thinking of like two spoiled twins at the moment, but whatever. So you got to, you got to say think of this as a minus 1. You can put the 1 there if you want. Minus 1 times 2x makes that a minus 2x. Minus 1 times 7 makes that a minus 7. So now we're looking at this, which we should put together like terms, and lo and behold, the 2x and the minus 2x are going to cancel each other. So 10 minus a 7. In the end, all you've got is a 3. Boy, that's weird. Just a 3. Well, I hope you enjoyed adding and subtracting. Really, it's all about like terms, maybe a little bit of distributing. Now we get to the good stuff, the multiplying. Except before we get to the good stuff, when we get to the better stuff, I got a really nifty law of exponent for you. We're going to be learning lots of laws of exponents. But for now, there's one that we're going to need right away. And it goes like this. Would you believe that a thing like this, 5x squared multiplying, let's do maybe 2x cubed. Would you believe that this comes out to 10x to the 5th? I hope you believe it. So the shortcut basically is we took the 5 and the 2 and we multiplied them to get the 10, right? And then the other thing we did is we took the exponents and we actually added them up. We added the exponents. So you're multiplying these are called coefficients, and I didn't put that on the vocab list because I barely ever used the word, but those are called coefficients. The 5 and the 2 out front, those multiply to give you the 10. But then the exponents add, the 2 and the 3 add to a 5. So critical point here. I'm going to ask you, do you believe it? Yes. And then I'm going to ask you, why do you believe it? Do you believe it because you've seen it before and it's a rule that you know? Well, hopefully you'll take it a little bit further than that. It's not just a rule. It actually, and this is the beauty of math, is when you start to just chew on it a little bit until you go, oh, I see how it's all hanging together. This is cool. So I'm going to suggest you look at it this way. 5x squared, you can break that up into its factors, right? A 5 times an x times an x. And now we're multiplying it by a 2x cubed, which is like a 2 times an x times an x times an x. This is supposed to be a multiply, not a subtract. These are all multiply. Okay, so that's what we've got. We've got a big string of multiplication. Now you can arrange multiplication in any order, right? 2 times 3, 3 times 2, it's all the same. 5 times 2, 2 times 5, it's all the same. So I'm going to put the 5 times the 2 first, and then I'm going to put the 2 x's, and then I'm going to put these last 3 x's. And you can see right away that you can multiply in any order. So if you want, you can take the 5 times 2, call it a 10, and then you can take all these together, call it an x to the 5th, and that's a dot. And as you can see, yeah, it worked. So just multiply the numbers down front, the coefficients, add your exponents. That's one of the most important rules of exponents. There's laws of exponents. There's like 3 that are humongously important, and that's one of them. So we're going to need that. So you'll see that show up right about now. So when it comes to multiplying 2 polynomials, this counts as 2 polynomials. 5x counts as a polynomial, right? It's a collection of terms of ax to the n. In this case, n is 1. It's a collection of one term in this case, but it counts. That is a polynomial. That is a polynomial. And the parentheses is telling us, hey, we should multiply those things. Keep your eye out, by the way. If there was a plus in front, you would not be multiplying these things, right? This is an addition, right? That's not what we have here. There's no addition symbol. There's no subtraction symbol. It's just 5x, boop, bumps right into 3x minus 6. That's telling you multiply. So distributing, we've actually seen this already when I said distribute the negatives when subtracting. So in this case, we're distributing the 5x. So you multiply the 5x times the 3x. 5 times 3 is 15, and this is going to be x squared. 2 ways to know that it's x squared. One way is that when you multiply the x times the x, you get x squared. The other way to know it is because there's a rule that says if you multiply x to the 1 times x to the 1, then you add the exponents and get x to the 2. So 2 ways of looking at it. Anyway, you get 15x squared. Then the 5x times a negative 6 is a negative 30x. So that's all you got to do there. Let's see what. Here's another example of distributing. Now this. Ooh, let me get the red out. I'm going to put a guy here that's supposed to be a guy going, watch out. It doesn't really look like it, so let's try that again. Well, actually, you know what? I'll just say, watch out. Let's have a guy who genuinely looks surprised. I'm watching out. You might be thinking those are like terms. Let's get this out of here. You might be thinking those are like terms, but they're not. Not like terms. And Why are they not like terms? They look like x's. And the reason is because this one is busy multiplying this x plus 1. Okay. You might also think, if you've heard of PEMDAS or order of operations, this multiplication is more important than this subtraction. You have to do the multiplying before you subtract. So I see this mistake more often than I would want to. So I'm just warning you about it right now. You see this 5x minus 2x, this is not like terms. What you have to do is you have to first do this distributing. So I've got my 5x, and when you distribute, take that negative with you. So that would be a minus 2x squared. Minus 2x times 1 is a minus 2x. Okay, that's better. Now you put together any like terms. Well, that's and that's. Those are the like terms. You should put the highest exponent first, and then the 5x and the negative 2x combine to a 3x. So that's your answer right there. Okay, so just, again, just watch out for that. Maybe just put a flag on it. How's that look? Just watch out for that. Okay, multiple distributing. This is where it gets fun. Multi-distributing. So you'll notice that distributing, backing up, you just had a thing in front. This was just a single term, I guess. Well, this polynomial has one term. Okay, so I just had a single thing in front, right? Even here, the 2x was the one thing multiplying into the x plus 1. But here we've got parentheses up against parentheses. So again, this is telling us to multiply. Parentheses up against parentheses means multiply. But you've got a 5x over here that has to multiply everybody. And then you've got a plus 6 that has to multiply everybody. So notice you've got 1, 2, 3, 4, 5, 6. You're going to end up with 6 terms here. So first, you do the 5x times the x squared. You get a 5x cubed, adding exponents. 1 plus 2 is 3. Next, 5x times this. That's going to be a negative 10x squared. Okay, cool. Next, 5x times 1 gives you 5x. Groovy, groovy, groovy. All right, let's get a different color maybe. Now it's the 6's turn. Think of it as a plus 6. Plus 6 times x squared is plus 6x squared. And I'm going to line it up underneath here. Remember, you're going to want to combine like terms, so I put the x squared under the x squared. It looks good. Okay. Now the 6 times the negative 2x makes a negative 12x, and I'll line that up with this x term. And then the 6 times the 1 gives me just a plus 6 out here in the middle of nowhere. And so now when I add this all together, I'm getting a 5x cubed. In fact, let's go back. Well, doesn't matter. 5x cubed. And then I got a minus 10 plus 6 is a negative 4x squared. Then I got a 5 minus 12 is a negative 7x. And then I got a plus 6. Call that the answer. Cool. I think it's a good time for you to try this one yourself. Maybe just pause for a bit. Make it. A lot of times with math, it's like you know what you're trying to do, but you got to do it. You got to do it without mistakes. I mean, that's half the battle is you got to know what to do. You say, I know what to do here. And then the other half is you have to do it without making a mistake. For me, that second part is often the biggest challenge. Is like, well, I know what I'm supposed to be doing, but can I do it? I don't know. Anyway, pause. Come back. Here we go. Multi-distributing. This 2x has to multiply everybody. Everybody here multiplies everybody here. So first the 2x multiplies this, this, and this, and then the negative 3 will multiply this, this, and this. Okay, that's the plan here. That's not an eraser. Okay, that's the plan. So when we go the 2x times the 4x squared, I get an 8x cubed. Cool. 2x times a negative 12x will be a negative 24x squared. 2x times the 9 is giving me a plus 18x. That takes care of the 2x. Now we attend to this minus 3 thing. Think of it as a minus 3 times a 4x squared is a minus, well, that's not going to go there. I'm going to keep my terms lined up. So I got a minus 12x squared lining up with the x squared. Basically, I'm going to be adding all this stuff together. And then the negative 3 times the negative 12x is a plus 36x. And then the negative 3 times the 9 makes a negative 27. And when I add these things together, notice the 8x cubed is all by itself. There's no other x cubed terms. The x squared terms, I got 2 of them. They're like terms. You can combine them. You can add them together. A negative 24 and a negative 12 makes a negative 36. x squared. And then the x terms, we got an 18 and a 36 makes a 54x. Cool. And don't forget your negative 27 at the end. Cool. Congratulate yourself. We just finished page 2. Right? No, page 3. Oh my gosh, we are cranking. So we did the terms, we did the add, subtract, we did the multiply. Oh, there's still another page. Okay, this is the funky stuff. Getting a little bit funkier. Now the good news is there's nothing new to learn. It's just the experience of, well, but I've never quite seen it looking like this before. It's all the same rules, if you will, but we just got to make sure we do it right. Okay, so I call this multi-distributing because there's like lots of stuff to multiply here. Notice there's 3 things. There's actually 3 things to multiply here. I got an x, I got an x minus 1, I got an x plus 1. I got 3 things to multiply here. Ask yourself, if you were going to multiply 2 times 3 times 4, how would you do it? You'd have choices. You could say, well, 2 times 3 is 6, and so 6 times 4 is 24. You could do it that way. You could, if you wanted to, do it this way. 3 times 4 is 12, so 2 times 12 is 24. You get the same answer, of course. The point is that you can multiply things together in any order, right? I mean, we kind of know this. 2 times 3 times 4 is the same as 4 times 3 times 2 is the same as 3 times whatever you want to do. 2 times 4, however you want to do it, right? You can always rearrange a multiplication. Putting it another way, you can always multiply things in any order you want. Now, why am I saying this? Because my approach, my personal approach, is to kind of start at the end and work backwards. So I'm going to leave this x here for the moment. And I'm going to work out what happens when I multiply all this stuff together. Okay. Now that's multi-distributing. So you do the old, this x has to multiply this x to give me an x squared. This x has to multiply a 1 to give me an x. This negative 1 has to multiply an x to give me a negative x. This negative 1 has to multiply a 1 to give me a negative 1. Okay, cool. So what have I got here? Well, actually, you know what I'm going to do? Since these are like terms, and actually since they cancel each other, this makes it rather convenient to first clean up the parentheses. So I got an x squared minus 1. Okay, cool. Again, those are just going away, plus x minus x. Now I distribute this stuff. So the x times the x squared is an x cubed, and the x times a minus 1 is a minus x. And there's your answer there. So it wasn't critical. It's not like it's a rule that says start at the right and multiply going the other way. But I find it quite useful myself. Here's another example. If you're feeling bold, you can try to multiply this out yourself. See if you get the same answer as me. Now, when I'm looking at this thing, I'm looking at multiplying 4 things together. We got this times this, and then times this, and then times this. Think of this as like a negative 1 out front. So it's kind of like a four-step multiplication process. So first, I'm going to leave this alone, and I'm going to leave this alone. Okay, cool. Now, let's multiply this stuff out. X times x is x squared. Let's try to do this all at once. X times this is negative x, but then I got plus 2x. So a negative x plus a 2x is a plus x. And then I've got a minus 2. Okay, cool. Now I'm going to leave the negative there for the moment. I'm going to multiply all this stuff out. So let's get a different color maybe. So the 2x times the x squared gives me a 2x cubed. And then the 2x times the x gives me a 2x squared. And then the 2x times this gives me a negative 4x. Negative 3 times x squared I could kind of put here. Negative 3 times x I can kind of put here. Negative 3 times negative 2 gives me a plus 6. That ends the parentheses. So what are we looking at now? I still got this negative in front. I want to clean up my parentheses here. There's the 2x cubed. Combining these gives me a minus x squared. Combining these gives me a minus 7x plus a 6. Okay. One more step. Actually, you know, it wouldn't be bad to leave your answer like that. But I would kind of, well, no, I guess if the instructions are depends on the instructions. If the instructions are something like, hey, simplify, you might say that's pretty simplified. But if the instructions are express as a polynomial in standard form, well, that's asking you to go a little bit further. A polynomial in standard form, this doesn't quite count as a polynomial in standard form. Why not? Because it's a multiplication of one polynomial, this polynomial is called -1, times another polynomial. So technically, this is not a polynomial in standard form. See what I'm saying here? So if it says, give me a polynomial in standard form, then, well, you kind of have to do this, distribute the negative stuff. -1 times this is -2x cubed. -1 times this is plus just x squared. And then you'd have, similarly, plus 7x, and then similarly, -6. There's your answer there. Looks like I've got 2 more of these to go, huh? Okay. Yep. This one here is a good one. This one gets a flag. It gets a flag because it's one of those problems that I see people kind of mess up a lot. Do not write this down. Do not write this down. If you write this down, you're going to have muscle memory telling you that it's the right thing to do. And muscle memory is very powerful sometimes. Do you ever drive the wrong way? You were wanting to go this way, but you went that way. It's because your muscles were remembering. You don't want your muscle to remember mistakes. Do not write this down. Because this is not this. Okay, again, I see this mistake a lot, but you got to be careful. What do exponents mean? Exponents mean to make 3 copies and multiply, right? So if you had 2 cubed, you would say, oh, that's 2 times 2 times 2 with a phone ringing in the background. You would say 2 times 2 times 2. Stupid phone, 2 more rings. Anyway, 2 times 2 times 2 is going to come out to 8, right? That's how you do exponents. So what are we doing here? We've got a cube on a parentheses. Well, that means you make 3 copies of the parentheses. And now you see why this is on the page called multi distributing. So again, it's not this. Please do not do that. You have to foil out all this stuff. You got a lot of monkey business here. You got to foil all this stuff out. So again, the way I like to do it is I like to first foil these things out, or I'm saying foil, but multi-distribute these things out. So x times x is an x squared plus an x plus another x, and then plus a 1. Okay. Now I have to multiply by this thing. X times x squared is x cubed plus a 2x squared plus an x squared plus a 2x plus a 1. And so when you add this all up, you're getting an x cubed by itself. You're getting 3x squareds. You're getting 3 x's. And you're getting a 1. Now compare this answer to that one. Not the same. You get all this extra stuff in the middle, right? So just please be alert to that, okay? Some people, like a lot of times you'll see something like this, right? This is called distributing. The 3 goes times the x, the 3 goes, okay, that's fine, but you don't do that game with an exponent. Exponents are different animals, okay? So please don't do that game with an exponent. Make 3 copies of the parentheses and multiply it all out. This is another one that I would invite you to pause the video here and give this one a twirl. Okay, you're back already. Cool. Come on, you. What are you doing to me? That's an eraser. Okay, cool. That's better. So, first, let's take a look at this thing. What do we got in front of our eyes here? Well, in this parentheses, I have a polynomial. Kind of a simple one, but a polynomial. In this parentheses, I have a polynomial. Note the subtraction separating these things. This is not a multiplication. This is a subtraction, right? On the other hand, note also the exponent. Now, the exponent is going to tell me to multiply something, and I got to do that multiplying first. So, I want the eraser. I just want the eraser. Wow, what is with this thing? Anyway, whatever. I'm freaking out. So anyway, we're going to do the squared first. So in other words, leave this here for the moment. Minus, and remember, there's a minus here, right? We're going to be subtracting, especially if I can figure out how to use the eraser. Okay, so this has to be an x minus 2, two copies, multiplying each other, like that. This is what we're looking at. So I got my 3 minus 2x, and I'm just going to leave that part alone for the moment. Now this is very important. When I go multiplying this stuff out, I really need to put that answer in parentheses. In fact, that's worth another red flag. A flag meaning remember the parentheses. You're subtracting an object. The object, we're sort of expanding the object, but the idea is you're subtracting this whole thing. So I'm subtracting this whole thing. So I got to make sure that in order to subtract the whole thing, that I put the whole thing in parentheses so that I will remember later that I'm subtracting the whole thing. And that's going to mean distributing. So anyway, show how this looks. So I got the x times the x gives me an x squared. I got a minus 2x. Then I got a minus 2x again. Then I got a minus 2 times minus 2 is a plus 4. Okay, cool. So like I was saying, why is that parentheses so important? Because now this negative here is going to be changing all of this. Changes that to a minus x squared, changes this to a plus 4x, changes this to a minus 4. So you can easily see that forgetting your parentheses is going to give you the very wrong answer. So anyway, these parentheses were just kind of, they just go away because it's by default there's a positive in front. You can think of it as a positive 1, and positive 1 times 3 is just take the parentheses off. Anyway, now we can finish this up. So I'm going to put like terms together. There's only one x squared term, I'm sorry. There's only one x squared term. Put that first. 4x and the negative 2x, those are like terms that they add together and give you a plus 2x. And then you got the 3 and the minus 4 gives you a minus 1. So here's your answer here. Cool. We are reaching the mountaintop. So this epilogue here, just two quick notes. You heard me say the word FOIL. And if you've heard this word before, you were probably the whole time saying, hey, when's you going to say FOIL? Okay, FOIL is just, how should I say this? FOIL is, I'll show you what FOIL is. This is what FOIL is. If you happen to have a special case where I have two here and 2 here, 2 terms here and 2 terms here. So I'm multiplying a binomial times a binomial, if you will. Well, when you multiply this using what I was calling multi-distributing, you would first take the x times the x. The x would also have to multiply the 3. Now the 2 has to multiply the x, and now the 2 has to multiply the 3. Okay, notice the x times the x is what you get by multiplying these two terms together, the two first terms, the first term in each parentheses. Notice the 3x is what you get by multiplying the things that are on the outside, right? Notice that the Notice that the 2x is what you get by multiplying the two things that are on the inside here. And notice that the 6 is what you get by multiplying the last things in the parentheses. And notice FOIL spells FOIL. Okay, so FOIL is a handy word. You heard me use it. We use it all the time, FOIL. The only reason I didn't say FOIL in the lecture is because it only applies to a very special case of I've got 2 terms times 2 terms. I've got a binomial times a binomial. Then you can say, oh, I'm FOILing. But oftentimes we don't have 2 terms times 2 terms. We might have, 2 terms times 3 terms or something. 3 terms times 3 terms, whatever. So the basic idea is the same. It's just is the same for all of these cases. It's just you take the first thing times everybody in the other one. Then you take the next thing times everybody in the other one. And if you had 3 terms, x squared plus x plus 7 and you wanted to multiply it by x squared minus x minus 5 or something, you would go this times this, 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 this times this. Now you couldn't call that FOIL because there's 9 different products here. It's multi-distributing. Anyway, that's a minor point really. And then the last point here is